All right, so we're cracking into homework set 30 now with problems 22 and 23 on page 451. They are sisters to 25 and 26 in your assignment. We can do these fairly quickly. That's why I wanted to do two of them. This is finding exact values of arc functions in this function, in this case of arc tangents. And to me, the thing I keep trying to remind you, I keep reminding you is that when you see an arc function, you've got to remember that it helps to remember that it's an angle. So this is the angle. This, I'm talking about this, is the angle whose tangent is root 3 over 3. Yep. Now, the reason I say that's helpful because, okay, if that thing is the angle, call it theta, whose tangent is root 3 over 3, let me draw a triangle for which that's the case. Well, here's one right here, okay? I don't even have to calculate that. I'm going to in a second. But there's a triangle with an angle theta in it, and the tangent of that angle theta is the opposite over the adjacent, root 3 over 3. That's all we've got to do is find out what theta is. Well, you know, a little bit easier said than done if you're just starting out at this. But let's start by finding the hypotenuse. The hypotenuse squared is this thing squared plus this thing squared. So 3 squared is 9. Root 3 squared is 3. 9 plus 3 is 12. Take the square root of the 12, and you have the tangent. And maybe it's more convenient to remember that 12 is 2 times 2 times 3. So I can write this as 2 root 3. Well, okay, well, maybe that still looks a little cryptic, but let me just divide. Let me just scale this triangle. This triangle, again, works perfectly well. I was looking for a triangle including this angle whose tangent is root 3 over 3, and I've got one, but I've got another one if I just scale all sides by 2 root 3. So let me draw that triangle. It has, if I divide this side by 2 root 3, a hypotenuse of 1. If I divide this side by 2 root 3, it's 1/2. And if I divide this side by 2 root 3, it's root 3 over 2. And now, maybe from your experience with unit circles, you recognize that as the 30, 60, 90 triangle, 30 degrees, or pi over 6 radians. Yeah. And that is the answer to this question. This arc tangent of root 3 over 3 turns out to be pi over 6. Great. Let's do the same thing now for arc tangent of root 3. I'm gonna call this theta. I'm gonna say, you know what? There's a theta right there, and it's in a triangle whose tangent is root 3. Opposite over the adjacent, root 3. All right, well, what's the hypotenuse in this case? It's 1 plus 3, it's 2. Is it not 2? This is 3 plus 1, add them up 4, take the square root 2. And now let me scale this triangle by dividing everybody by the hypotenuse so that I get a hypotenuse of 1, root 3 over 2, 1/2. And now you go, oh my gosh, this is 30 degrees in this case because the 30, 60, 90 triangle has the property that the hypotenuse, if the hypotenuse is 1, that the side opposite 30 degrees is 1/2, which is exactly what we have here, making this angle across from the root 3 over 2, 60. So the angle theta is 60 degrees. 60 degrees is pi over 3. And the answer to this problem is pi over 3. So there's the technique I recommend, recognizing the arc functions as angles, treating them geometrically in the appropriate triangle, deriving the value you want from the ratios of the side. And it's more than that. You're really making use of not just the ratios of the sides, but the unit circle formalism. Right, we're moving on.